The relationships we've differentiated so far have all been functions in which one variable is written explicitly in terms of another variable. So for example, y equals x squared plus 3x, or y equals the square root of x minus 2, y equals the sine of x. But not all relationships are defined explicitly. Some of them are defined implicitly. So for example, the unit circle. This would be defined implicitly, where it's not one variable is expressed in terms of the other variable. That's the formula of a unit circle. So although this is not a function, you can see it doesn't pass that vertical line test, we can still, it doesn't prevent us from finding the derivative, since the derivative represents the slope of the tangent line. So there's still rate of change that's happening at each different x value. And some of the times this is going to be important for us to know these relationships. So implicit differentiation. To perform implicit differentiation on an equation that defines y implicitly in terms of a variable x, use the following steps. Take the derivative of both sides of the equation. Keep in mind that y is a function of x. Consequently, whereas the derivative with respect to x of sine of x is cosine of x, if we're taking the derivative with respect to x of the sine of y, so notice this is y, not x. So this is why we learn the chain rule first, because now we've gotten used to taking the derivative of a function with respect to the inside function. So if we're doing that, this is where that chain rule comes into effect. And so the derivative of this would be the derivative of the outside with respect to the inside times the derivative of the inside function. Because we must use the chain rule to differentiate the sine of y with respect to x. So once you have that, then our whole goal is, and we can actually rewrite this as dy dx. Our whole goal is we're trying to solve for dy dx. So what you want to do once you've done that is you solve for dy over dx. So let's look at this in action. Let's look at an example. Find the derivative of y with respect to x by implicit differentiation for the equation x squared plus y squared equals 25. So we can see this is an implicitly defined equation. So following the steps from that last slide, first step is to take the derivative of both sides. So taking the derivative of the left side, and we'll take the derivative of the right side. All right, so let's apply the derivative laws. So I can, since these are two things getting added together, I can take the derivative of each piece and add those together. All right, so the derivative with respect to x of x squared is 2x. Okay, this is where we've got the chain rule, because this is the derivative with respect to x of some function y. Okay, so this is where that outside, inside. So the outside function would be 2y times the derivative of y with respect to x. So times the derivative of that inside function, whatever that is, with respect to x. So again, it's applying that chain rule. We have to add, we can't just say 2x like we did here. We can't just say 2y because y is some function of x. So that's why we have to add in this dy dx part. Equals 0. And then the second step is to solve for dy over dx. So in order to do that, let's subtract 2x from both sides. And I'm going to get 2y dy dx equals negative 2x. So divide both sides by 2y to get that dy dx by itself. And I get negative x over y. Okay. Find the derivative of y with respect to x by implicit differentiation for the equation x squared sine of y plus y equals 4x plus 3. Okay, so this is an implicit differentiation because I don't have y equals and everything else is in terms of x. So we will use the steps for solving and doing implicit differentiation. So that first step is to take the derivative of both sides. So I always write this out. So it's the derivative with respect to x of x cubed sine of y plus y equals the derivative with respect to x of 4x plus 3. Okay, so since I'm adding two functions on the left-hand side, I can just apply that derivative to each piece. Oops, derivative with respect to x of y. Okay. All right, so now what I'm going to have to do is now I can take the derivative of each of these pieces. So looking at the left-hand side, I see that this first term, the x squared or x cubed sine of y, this is two functions getting multiplied together. So I'm going to have to apply the product property. So the product property, this is going to be x cubed, the first function, derivative with respect to x of the second, plus the second derivative with respect to x of the first, and then I still have this. I'll do the rest of these pieces after. I'm just going to kind of do it all at once. All right, so now let's go through and take these derivatives. So x cubed, the sine of y, so taking the derivative with respect to x with the sine of y. So this is where that chain rule comes in. So the outside function is the sine function, so that's going to be the cosine of y, and then times dy dx. Plus, I've got the sine of y, and then I'm taking the derivative of x cubed, which is 3x squared. The derivative of y with respect to x, or sorry, derivative of y with respect to x is going to be the derivative of y with respect to x. The outside function, y, if I take that derivative, I'm going to get 1, and then times the derivative of dy dx. So that equals 4. Okay, so our entire goal is to solve for this dy dx. So what I'm going to do is I'm going to take this term, because this is the only term on that left-hand side that does not involve a dy dx, and I'm going to move that over by subtracting it from both sides. So when I do that, I get x cubed cosine of y times dy dx plus dy dx equals 4 minus, I'm going to move that 3x squared to be in front, so 3x squared sine of y. So now I have all the dy dx's on one side, which is great because I can factor that out now. It's just like if we had an equation where we had something like 5x plus x, or 5x squared plus x, we could factor that x out and we'd be left with that. So that's kind of the same idea I'm doing here. I'm treating this like each of these has this term. So I'm going to factor that dy dx out, and when I do, this whole term is going to be left with just x cubed cosine of y, and this is just left with a 1. So that way if I distributed this through, I would get this exact same line. And then that equals 4 minus 3x squared sine of y. So now it's just I've got dy dx times this expression, so in order to get rid of that, we will divide by it. So we are going to be left with dy over dx equals 4 minus 3x squared sine of y all over x cubed cosine of y plus 1.